Welcome back, guys. This is question 6.2, and the statement of this question is: suppose x follows a continuous uniform distribution from 1 to 5. Okay, so determine the conditional probability that x is greater than 2.5 given that x is less than or equal to 4. Okay, so what does it mean? Let me first draw the distribution here to see or illustrate it visually. So this is, let me call it x. Okay, and this is f of x. Okay, so if I want to draw it, so it would be what it is from 1 to 5. Okay, so from 1 to 5, this is the continuous uniform distribution, so therefore the value of it will remain the same and it will be constant here. Okay, so what should be the value of it here? What is the value which must be here? So in order to calculate it, I can use the formula here for f of x, and that is 1 over b minus a. Okay, so here the value of b is 5, the value of a is 1. So let me write it 1 over 5 minus 1. So this is 1 by 4. Okay, so therefore this one is what? This one is 1 divided by 4, which will remain the same. Okay, so this is what we have found out. Now on the basis of it, this is the conditional probability, but we can here follow two methods to solve this question. Let me solve it by using the first method, and in that method, let me have it here. In that method, let me call it method number 1. In that method, I have to use the probability that so x is greater than 2.5 given that x is less than 4. Okay, so what is this? According to the conditional probability, we have to write x is greater than 2.5 and the probability that x is less than 4 divided by the probability that s is less than or equal to 4. Okay, here we can see that these two are connected, so therefore we can write them combinedly as what? Okay, let me write it in combined method. So it would be x is greater than 2.5 and less than or equal to 4. Okay, so there we have it here. Okay, so in order to find both of them, what do we have to do? We have to use the similar formula for finding the probability density function here. Probability that x is less than or equal to 4, it will be from 1 to 4, because all the values from 4 to 1 here will be the ones which are included in this distribution. And also here, what do we have to do? Here we have to write here f of x dx. Okay, we have already found out the value of f of x, so therefore let me write it here. Okay, the value of it, so it would be 1 over 4 d of x, and finding it out, it would be 1 by 4 and x 1 4. Okay, or simplifying it, what would we get? This would be 4 minus 1 divided by 4, so it would be 3 by 4, the value of it here. Okay, also the probability that x is greater than 2.5 and less than or equal to 4, here the only difference would be to make it from 2.5 to 4. Okay, and also the fx will remain the same and it will be here. Okay, also writing it, we will get the similar one, but here the limits would be from 2.5 to 4. Okay, and it would be what? 4 minus 2.5 is 1.5 divided by 4. Okay, taking both of these values now. Okay, so it is what? Let me write it here. So 1.5 divided by 4 divided by 3 over 4, these two will cancel out, it would be here. So ultimately we will get 1 by 2. So the answer of it is what? The answer of it is 1 by 2. Okay, so that is what? That is the solution by using the first method. In second method, let me draw the distribution here. This is the distribution. Okay, so this is the distribution, but as we are not given here in this condition all the values upper than 4, so therefore we are confining ourselves from 1 to 4. Okay, so these are the values. Now similarly here, this is what this is, this one which we have seen here, which are x is less than or equal to 4. Similarly, according to the other condition, this is greater than 2.5, while it should confine between 2.5 and 4. So therefore, it will be here as, let me write it from 2.5 to 4. Okay, so these are the two areas. This one is the first, let me call it A, and this one is B. Okay, so in order to find the probability that x is greater than 2.5, given that x is less than or equal to 4, here we can use these two areas. Okay, so in these two areas, the higher one or the area we want to find here is this one. So therefore it would be 4 minus 2.5, which is the length, multiplied it with this height. Okay, this is the length and this is the height, so this is 1 by 4 as we have already found out. And similarly, this is the total area. Okay, so it would be 4 minus 1, multiplying it with this height. Okay, so it was 1 by 4 as well. These two will cancel out, and from it would be 1.5. This is 4 minus 1 is 3, so ultimately we would get the answer of it 1 by 2 as well. So the two answers are equivalent with each other. Okay, what we have to keep in our mind that here we have used the conventional method, in which this is the area whose probability we want to find out, while this is the total area. And by using the conventional method or the conventional principle of probability, that the probability of an area is equal to the subset of the area divided by the total area. Okay, so we have used the similar formulation here and we have found the answer which is similar one as that of the original one. Okay, so that's it for today, in which we have seen the solution of question 6.2. If you have any question, you can ask me in the comment box. See you soon.